Assalamualaikum everyone. My name is Amna. My registration number is 23TE29. Today I will present my assignment on logical agents and inference mechanism in artificial intelligence. I will explain how AI system use logic, knowledge and reasoning to make intelligent decision. The slide 2 is about agenda. In this presentation I will cover artificial intelligence, logical agents, knowledge base, propositional logical resolution, forward chaining, backward chaining, first order logic, quantifier, interference, unification and applications of AI. In third slide I am going to discuss the artificial intelligence introduction, in which we tell you that artificial intelligence is a branch of computer science that enables machines to perform tasks that normally requires human intelligence. These include learning from data, reasoning logically, solving problem and making decision. Examples include ChatGPT, self-driving cars, virtual assistant and medical expert. Now in the slide 4 we have a logical agent, in which intelligence system uses logic and reasoning to make decision. It receives input from environment using sensors, store information, and in a knowledge based process it using an interference engine and produces output through actions. This allow machines to behave intelligently based on rules and facts. In the image you can see a block diagram showing environment, sensor, knowledge based, inference engine and action. Then we have knowledge base is a structured collection of facts and rules used by an AI system. For example, if it is raining and we know that rain makes road wet, the system can logically conclude that roads are wet. The knowledge base is important because it helps the system store information and make decisions. In the image that I attached here, you can see a network style diagram showing facts, rules and conclusion connected like a reasoning system. Then we have logical agents have several advantages. They provide accurate reasoning, consistent decision making, reusable knowledge and easy debugging. However, they also have limitations such as difficulty handling uncertainty, need for complete knowledge and high computational cost in complex system. So then we have propositional logic deals with simple statements that are either true or false. It uses logical operators like and, or, not and implies to combine statement. For example, if P means it is raining and Q mean roads are wet, then P implies Q means rain causes wet roads. Then in the image you can see the logical gate symbol and basic propositional logic expressions connected in a clean diagram. Then we have logic resolution. Resolution is a logical inference method used to derive conclusions by eliminating contradictions. It helps AI system check whether a system is true based on given facts and rules. It is widely used in automated theorem proving and expert systems. And in the diagram you see a step-by-step logical deduction tree showing two statements merging into a conclusion. Resolution example. For example, in this example, if we know that light being on make the room bright and the light is on, we can conclude that the room is bright. This shows how logical reasoning helps AI derive new knowledge from existing facts. Then in the side image you can see here we have forward chaining. In the forward chaining, it is a data driven reasoning method. In this, it starts with known facts and applies rules steps by step to guarantee new conclusions until a final result is reached. It is useful when we want to explore all possible outcomes from given data. And in the image attached you can see a flow chart starting from facts moving towards through rules to final conclusion. Then we have backward chaining is basically a goal driven method. It starts with a goal and works backward to check which facts can support that goal. It is commonly used in expert system for diagnosis and problem solving. And in the graph you can see a backward reverse flow chart starting from goal and moving backward to facts. Then we have a difference between forward and backward chaining. Forward chaining starts from facts and moves towards conclusion, while backward chaining starts from a goal and works backward to verify facts. Forward chaining is useful when we want all possible results, while backward chaining is efficient for specific queries. Then we have FOL, first order logic. First order logic is more powerful than propositional logic because it includes objects, variable, predicates and relationships. For example, instead of just saying human, we can say human Ali to represent a specific person. This makes FOL more expressive and useful for complex systems. Then we have quantifiers in FOL. FOL use quantifiers to express general knowledge. The universal quantifier means for all, such as all humans are mortal. The existential quantifier means there exists, such as at least one student exists. They allow us to represent real world knowledge more accurately. Then we have inference in FOL. Inference in first order logic is the process of deriving new facts from existing knowledge. For example, if all humans are mortal and Socrates is a human, then Socrates must be mortal. This shows how logical reasoning works in AI system. Then we have unification. Unification is the process of matching two logical expressions by finding suitable substitution. For example, loves X ice cream becomes loves Ali ice cream when X is replaced by Ali. It is the key technique used in AI reasoning and programming language like Prolong. Then we have propositional versus first order logic. Logic uses simple true or false statement, when first order logic allows variable and relationships. FOL is more powerful because it can represent real world knowledge in a structured way. Therefore, it is widely used in advanced AI systems. Then we have application and conclusion. Logical reasoning is widely used in AI applications such as expert system, robotics, chatbots, medical diagnosis, virtual assistant. In conclusion, logical agents use knowledge and reasoning resolution, help derive conclusion, chaining method, help in inference, and FOL provides powerful knowledge representation. Thank you for listening. Allah Hafiz.